Welcome to my channel. In this video, you're going to learn about quartiles, deciles, and percentiles, which are the measures of position. Now, what do we mean by quartiles, deciles, and percentiles? Quartiles are values that divide the set of data into 4 equal parts. Deciles are values that divide the set of data into 10 equal parts. And percentiles are values that divide the set of data into 100 equal parts. I'm going to illustrate more about this. So let's start with quartile. So you notice here, this is 0. So 1, 2, 3, 4. So we divide this into 4 equal parts. And if you notice, there are 25, 25, 25% each. And from 0, here, from the minimum value here to the first cut here, that is what we call the first quartile. That is the 25th. And from 0 to the second cut there, or the middle, is what we call the second quartile, and that's the 50th. And the third cut there is what we call the third quartile, or the 75th. Okay? Now, look at this one. The second quartile is also what we call the middle, or known also as the median. Okay, it means that half of the data here belongs to the lower quartile, and half of the data is on the upper quartile. Okay, next, what about deciles? So look at this one, dividing the data into 10 equal parts. So each part now is 10% to make it equal to 100%. Okay, now here, D sub 1 means that's first decile. Deci means 10. Okay, so that is first decile, second decile, which is 20th. From here, that is 10, 20th, 30th, and so on and so forth. So D sub 3 equivalent to 30th. Okay? And here, this is D sub 5 or 5th decile. Okay? And that is equivalent to second quartile, which is the 50th value. D sub 7, D sub 8, D sub 9, and of course, this is D sub 10, or what we call, this is the 100th here. So 90th, 80th, D7 means 70th. Okay, now here, okay, so we have the 10th and the 90th. What about percentiles? Percentiles dividing into 100 equal parts. But here, I showed only, here I count by 10. Okay, so it means this is 10, 20, means there are 1, 2, 3, 4, 5. I just showed the 10 because it's quite long. So 10 percentile, 20th percentile, 30th percentile, 40 and 50th percentile. After 50th, we have 60, 70, 80, 90, and of course 100 percentile here. This is 0 percentile. So we don't usually solve for those 0 and 100. So here, the first decile and the 10 percentile are the same, are equal. And look at this one. The median, second quartile, 5th decile, and the 50th percentile, they are equal, which means that half of the data above here and below the median. Okay, now, so now let's focus first on quartiles, then after this, deciles, then percentiles. So for quartiles, we know that the middle here is also known as the median. And on the left side here, this is the lower half or the lower quartile. And from here, going here is what we call the upper quartile. That is the 25th, 50th, and the 75th. Okay, so when we say first quartile, it means that 25% of the data is below this point. If this is the first quartile, it means that 25% of the data is below this point. Okay? And the other set of data is above this point, which is 75%. Other way around of explaining that. Now, what about second quartile? Second quartile is the median of the data set. It means that 50% of the data is below this point, or you can say that 50% of the data is above this point. Now, what about the third quartile? Is the middle value between the median and the highest value of the data set. It means that 75% of the data is below this point. Okay, let's say this is the quartile, third quartile here. It means that 75% of the data set is below this point and 25% of the data set above this point. Okay, because this is 75. So there is 25 here, there is this is 75. From 0 to here, 75. From here up to here, that is 25 only. Let's have an example on how to solve for the quartile. So we're going to solve the first, the second, and the third quartile. Okay, now first arrange the data in order. Check. Okay, so far this set of data is already in order. Divide the data into 4 equal parts, and the quartiles are the values where the cuts are. Okay, now there are 7 values here. And the middle now is, you need to start always with the second quartile because that's the median, the middle. So there are 7 values here. It means 8 is the median or the middle, and that is the second quartile, and that is 8. Okay, now we have here the lower half and the upper half. You need to find the median of these values here. So there are 3, and the median therefore is 5, the median or the middle. And that middle of the lower half is what we call the first quartile. And the middle of, or the median of the upper half is what we call the third quartile. So we have now the first quartile is equal to 5 and the third quartile is equal to 11. Okay, now there's another way on how you can solve the first, the second, and the third quartile by using the formula. Now, it's up to your teacher if he wants you to use the formula or just doing what I did here. But I'm going to show also how to use the formula. So here's the formula in finding for the quartiles. That is Q sub K is equal to K times N plus 1 divided by 4. So K stands for, it depends on you if you're going to solve for the first, the second, and the third. So K, and then N, which is the number of items. So there are 7 here, and divided by 4 because we divide the items into 4 quarters. Okay, so Q sub 1 means the first quartile, that is 1, and the value of N is 7, 7 plus 1, that is 8. So that is divided by 4, so 8 times 1 is still 8, divided by 4 is equal to 2. Okay, what is this value 2? Is this the quartile? No, this is the position of the quartile. It means it's on the second item. Okay, so look at this one, second here. For the first item is 4, the second item is 5. That's why the first quartile is equal to 5. It's on the second item. Okay, what about the third quartile? Using the formula, instead of K, sorry, K, that is 3. So that is now 7 plus 1. That is 8 times 3. That is 24. 24 divided by 4. And that is equal to 6. Okay? Sixth. Now, check. 1, 2, 3, 4, 5, 6, 11. So 11 is the third quartile. The value of the third quartile. It's 11. Okay, look at this one. So we have 1, 2, 3, 4, 5, 6, 7, 8. And let's check if this is already arranged. Okay, no. So we need to arrange. So 3, okay. Then 6, but we have 5. We have 5. So 5 and 5. Then 6, 9, 10, 15, and 16. Okay, make sure that you didn't miss any number here. So this is now the arranged data. Okay, so now if you're going to find the middle, start always with the second quartile, right? The middle. So we have 1, 2, 3, 4. Then 1, 2, 3, 4. So we have two middle here, the 6 and the 9. Two numbers. So how are we going to find the second quartile for that? So that means that here is the second quartile. Now, if you're going to find the middle or the median for that, simply you are just going to add these two numbers and divide it by 2. So 6 plus 9 divided by 2, that is 15, divided by 2, that is equal to 7.5. So that's the value of the second quartile, 7.5. Okay? Now, here, how many numbers here? So we have here from this, the median. This is the median or the second quartile. So 1, 2, 3, 4. Okay? From here, 1, 2, 3, 4. So it means we can find the middle number here or the median of the lower half. Okay? 1, 2, 1, 2. So the middle is here. Okay? And you can just simply find the average of this, 5 plus 5, and that is 10 divided by 2, and that is still 5. Okay, so that's the first quartile. And here, 10, the middle here is also the third quartile. That is the median of the upper quartile. Okay, now, first quartile is equal to 5. Very easy here, right? Now, for the third quartile, if you just simply want to get the average of 10 plus 15 divided by 2, the average of 10 and 15, that is 12.5 actually. 12.5, that is the third quartile. Now, it depends on your teacher if he just want to get the average here. Because there is another way. If you want to get the exact value here, if you're going to use the formula, there will be a difference with the value here. So you need to pay attention if your teacher just wants simply to get the average, or if he is very detailed and he wants to really get the exact value there by using the formula. Okay, let's see. Take note of this. If you're going to use simply getting the average of these two numbers here, the result is 12.5. What about if we are going to get the third quartile using the formula? What should be the value? Now here, I'm going to show to you what's the difference if we are just going to use the average or applying the formula. But you need to pay attention if your teacher just wants you to get the average, so you're just going to use this one, that is 12.5. But if he wants to use the formula, he wants you to use the formula, you need to follow this formula. And let's see the difference. Okay, so now here, K is 3. So we're just going to substitute all those. K is 3, N is 8 plus 1 divided by 4. So we have 8 plus 1, that is 9 times 3, that is equal to 27. Divided by 4, and that is equal to 6.75. Okay, what is this 6.75? This 6.75 means that the sixth place. And what is the sixth place here? 1, 2, 3, 4, 5, 6. Number 10 is on the sixth place. And we have this 0.75. So here, if you're going to use the formula, it's really very detailed. 0.75. Okay? What is that 0.75? That 0.75 is, of course, between 10 and 15, right? So what are you going to do is, to get the exact value here, is 6 means the sixth term, plus you are going to get the difference of this sixth place and the seventh place. Okay, so multiply that with 0.75. 7 minus the 6. So let's substitute. What is the sixth place? The sixth place is 10. Because 1, 2, 3, 4, 5, 6. So 10. Okay, so 10 plus 0.75, and the difference between 15 and 10 is 5. So that is now equal to 10 plus 0.75 times 5. Subtract this one, 15 minus 10, that is 5, times 0.75, and then add that to 10. So just copy 10. 0.75 times 5 is 3.75, plus 10, that is 13.75. Oh, you see the difference here? The scores under this third quartiles is 13.75. Here, 13.75. Now, if you're going to get the average, we only have 12.5. So this is why I want to show to you the two ways of solving. But it depends on your teacher if he just wants simply the average or using the formula. But using the formula, that's how you're going to solve it. Okay, now this time, we're going to solve for the deciles. Using the formula, so same formula except for the denominator this time is 10 because we are dividing the set of data into 10 equal parts. So again, d sub k, k means is if you want to solve for the first, second, third, or fifth decile. And the fifth decile means the 50th. It's by 10, right? Okay, so what are going to do is to simply substitute. If you want to solve for d sub 5 or the fifth decile, that is equal k is 5 and n is still 8. 8 plus 1, that is 9. And this time divided by 10. So this is simply 9. 9 times 5, that is 45. And 45 divided by 10 is 4.5. Okay, so 4.5 means that 4 And then we have zero point 0.5. So 1, 2, 3, 4. This is the fourth. And then 0.5. Okay, so it's between 11 and 12. So simply, what we're going to do is the fourth, you can actually find it here easily. You can just get the average here, but we're just going to use the formula. The fourth plus 0.5, because this is zero point 0.5, the decimals is always here. So 0.5. So 0.5 times the fifth minus the fourth. Okay. So here, just going to put like that. So this is the fourth, 1, 2, 3, 4. So this is the fourth, 11, and this is the fifth. So we're going to get the difference of that, and that is only 1. 12 minus 11, that is only 1. So that is now 11. That's the fourth term, or the fourth data there, plus, copy 0.5 times 1. 1 is the difference of 12 and 11. And simply, zero point 0.5 times 1 is 0.5. So that is 11.5. 11 plus 0.5 is 11.5. Okay? Or simply, if you want to get the average here, that is 11 plus 12 divided by 2, that is 11.5. Okay, but I want to show using the formula. So what does it mean now? 11.5, that is the 50th. Okay? So 11.5 is the 50th. It's not only the fifth term, okay, or the fifth in the rank. It's different from the 50th because decile means by 10. Or you can say it's the 50th percentile. But I'm gonna use this is decile, and we are going to discuss on the percentile next. So you can see that they are just equal. I showed already a while ago about the fifth decile, the second quartile, and the 50th percentiles are just equal, right? Now here, next, you want to try this? You can pause the video and solve it first, then you can unpause if you're ready. So you're going to solve for the 8th decile, or simply the 80th. So same formula here, just substitute the value of k and n. And since we are using the same value, so we have same 8 and then times 8 plus 1. That is divided by 10. So that is 72 because this is 8 plus 1, 9 times 8. That is 72 divided by 10. That is 7.2. Okay, 7. Here, 7. So 1, 2, 3, 4, 5, 6, 7. That is number 15. This is the 7th here. And we have the 0.2. To get the exact 0.2, what are we going to do is, again, we're going to get the difference of this 7th and 8th. Okay, the 7th and 8th. So we are, means that, sorry. So the sub 8, 7 plus the 0.2 times the difference of the 8th and the 7th value there. So that is equal to, what is the 7th now? 15. That's the 7th value. 1, 2, 3, 4, 5, 6, 7. So 15. Just substitute 15 plus 18 minus 3. So 0.2 times 3 because 18 minus 15 is 3. And then 0.2, multiply first before adding. So 0.2 times 3, that is 0.6 plus 15. And that is equal to 15.6. Okay? That is now the value. 15.6 here between 15 and 18. What does it mean? 15.6 is at the 80th percentile. Okay, 80th. Because this is 100. From 0 to 100, of course. Okay, so now, let's proceed to percentile. Okay, so this time we're going to use the formula in using or solving for the percentiles that we want. So the difference is that this is P sub K percentile. K again is the percentile that you want to solve. If it can be 10, 20th, or 30th, 70. This time we're going to solve for the 70th percentile. And the denominator here now is 100 because we divide the set of data into 100 equal parts. K, that's the 70. Again, substitute the value of K, 70. And then we have 8 plus 1 because we used the same data a while ago, divided by 100. Now we can simplify this 70 and 100 to make it easier. We're just going to cancel 1 0 here, and it becomes 7 over 10. 7 over 10 times 8 plus 1, or that is 9. So we have now 9 times 7. That is 63 divided by 10. And that is equal to 6.3. Now, 6.3 means 6. The sixth item, 1, 2, 3, 4, 5, 6. Okay, so 14, sorry. 14 is the 6 items, 1, 2, 3, 4, 5, 6. So it means we need to get the difference of these two in order to get the exact value there. So 6, the same for pattern or formula. We need to get the 6th term there plus the 0.3 here, 0.3 times the difference of the 7th and the 6th term. Okay, so now, what is now the value of the 6th term? That's 14. This is the 6. Okay, and this is the 7th term. Okay, we're just going to get the difference of that. So that is 14, and then the difference is only 1. 15 minus 14 is 1. So 0.3 times 1 is still equal to 0.3. So that is equal to 14 plus 0.3 is equal to 14.3. Okay, look at this one. 14.3 is the 70th percentile. Okay, 14.3 is at 70th percentile. Okay, but if your teacher just wants to get the average, look at the difference. If you're going to get the average only, 14 plus 15 divided by 2, that is 14.5. And here is 14.3. Okay? So you need to pay attention for that. 14.3 is the 70th percentile. Or 14 plus 15 divided by 2, that is equal to 14.5. So see the difference of here. Okay, so you need to ask first if your teacher will just going to accept the average or using the formula. Now, there is another way that this percentile is very useful. Let's say you want to know what percentile is your score. Let's say your score is 12. So 12 is here. Okay? You want to know what is the percentile rank for that. So this is now the formula that you are going to use. X plus 0.5 times y divided by n times 100. So what does X means? X, these are the numbers below this one. So 1, 2, 3, 4. There are 4 numbers here below this scores that you want to find. And what is the value of Y? Y is if how many 12 are there in the list, and since there is only one here, so the value of Y is 1. Let's substitute that. So 4, again 4, 1, 2, 3, 4. There are 4 numbers below this score plus 0.5 times 1. If there are 2 12s here, it means times 2. Divided by n, which is the number of data, and that is equal to 8. So 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then times 100. So now we can do this one first here. This is now equal to 0.5 times 1 is still 0.5. 4 plus 0.5, that is 4.5 divided by 8 times 100. 4.5 times 100 is 450 divided by 8, and that is equal to 56.25. It means that the percentile rank of your score, which is 12, is at 56.25. Okay, or approximate 56. Okay, so the 56 percentile is 12, or you can say that 12 is at 56 percentile. Okay, if the scores are a lot here, let's say the data sets here are more compared to this, you can really get the closer value here. And that would be on the next video about finding the quartiles, deciles, and percentiles of group data. Okay, that's all for this video, and thank you for watching. See you on the next one. Don't forget to subscribe to my channel and share my videos. See you on the next one. Bye.